Hi everyone, for our 7th grade Elevate group, today students will be solving inequalities. So yesterday students spent time understanding what inequalities were, specifically around their symbols, and solving one side of the equation to see if the statement was true or not true. Today students will be solving inequalities. And so, specifically around using substitution. So, students will have examples like this or questions like this where they're being asked, does the number 3 make the inequality true? Right? So, as we're looking at 4 plus n is less than 10, we see that n is a variable. And so, what they want is for us to substitute the number 3 for that variable n, right? So what we are doing is we're saying, okay, 4 plus 3 instead of 4 plus n. And saying, is it less than 10? So we know that 4 plus 3 is 7. And 7 is less than 10. So it is a true inequality statement. That's the work that we did yesterday, right? Well, not around the substitution, but we started here yesterday. A big chunk of what students are going to be doing today is around solution sets. So they're going to be using this concept of substitution. However, they're going to be given a solution set. So 3 or 4 different numbers to substitute in the variables, So we are trying to see, in other words, do the numbers 8, 14, and 18 work for this inequality? So we will have to literally go one by one. We have here 5 plus x is greater than or equal to 19. So we'll have to, again, substitute each number for x and then simplify. The first number that we were given is 8. And so we're going to plug in 8 for x. So instead of doing 5 plus x, we'll do 5 plus 8. And ask ourselves, is 5 plus 8 greater than or equal to 19? Right? Well, we know that 5 plus 8 is 13. Is 13 greater than 19? No. Is 13 equal to 19? No. So this is an incorrect or inequality statement that is not true. 8 is not in the solution set. 8 does not work, right? So students can go ahead and cross out that 8 and say it doesn't work, right? We're not done because, again, they gave us a solution set. They gave us 3 numbers that we have to substitute. We only just did 8, so now let's jump into 14. Same thing. Instead of doing 5 plus x, we are now going to do 5 plus 14. 5 plus 14 is 19. Is 19 greater than 19? No. But is 19 equal to 19? Yes, it is. So this works. 14 is in the solution set. Then the last one we are going to do is 18. Again, instead of doing 5 plus x, we are going to substitute 18 for x. So we're going to do 5 plus 18 and ask ourselves, is 5 plus 18 greater than or equal to 19? So when we do 5 plus 18, we get 23. Is 23 greater than 19? Yep. This works. So 18 is in the solution set. So based on that, you are going to go ahead and model for students question B. And it's the exact same strategy that I used up here during the introduction, where you are given a solution set. You're given 38, 40, and 42. You are going to plug each of those numbers in as a substitution for B and then subtract 26, right? So 38 minus 26, is that less than 15? Yes or no? What's the inequality statement? And then we're saying yes or no, okay? Then identifying which of these numbers, if any at all, are in the solution set. So for this example, only 38 and 40 worked. So you'll model B, and then you'll jump into also modeling for students question 1 and question 4, just so they know how to, well, I'll say maybe you don't have to model question 4, but definitely model question 1 just to show students what it looks like just to substitute one number. So for question 1, you have 14 plus x is greater than or equal to 28. And for this question, students are substituting 16 for questions 1. They're not going to do 2, but they're also going to substitute 16 for question 3. So when they do 14 plus 16, they get 30. Is 30 greater than 28? Yep. So this works. They'll do the same thing for 3. And then for questions 4, 5, and 6, students are using the solution sets to identify which numbers are a solution in the equality. There's no exit ticket for today.